In this video, we're going to talk about linear equations in two variables. And let's just recall from past videos that a solution to an equation with one variable is one number that makes our equation true. So for example, here with x plus 3 equals 7, the solution is x equals to 4. And that's our number that makes that equation true. When you start talking about equations with two variables, then a solution is going to consist of two numbers, one for each of the variables. And we're going to represent our solutions by an order pair, a pair in which the order matters. Okay? So let's look at an example. So our first example, we have the equation y equals 5x, and one solution is x equals to 1, y equals to 5. So let's check that. We're going to check that by substitution. We substitute in 5 for y and a 1 for x into the equation. And so that 5 was our y and that 1 is our x value. Notice that's our equation. And we just know that 5 does equal 5 times 1. So we write the solution as the order pair 1, 5. You put that in order, you put your x before your y, and we say that 1, 5 is the solution to the equation y equals 5x. Alright, another solution is when x is 2, y equals 10. So 10, let's substitute and check that. 10 equals 5 times 2. Again, our 10 was replaced into our y, and our 2 was substituted into our x, and so we do get 10 equals 10. So we say that 2, 10 is the solution to y equals 5x. That's another solution. So we've already found 2. And here's the third one. When x is 3, y equals 15, as you can see by substitution. So 315 is also a solution to y equals 5x. And in fact, really, y equals 5x has an infinite number of solutions, because for every value of x that we choose, for every number that we choose for x, we can find a y value that's going to make the equation true. So this linear equation in two variables has an infinite number of solutions. So in the first exercise, let's just determine whether the given order pair is a solution to the equation that's given. So in our first problem, we have the linear equation 2x plus y equals 4. And we're going to see if the order pair negative 1/2, 3 is a solution by using substitution. So we will substitute the negative 1/2 for x and the 3 for y. And we're going to see if we get that 4 that's on the right-hand side of this equation. So as you know, 2 is 2 over 1, and we need to do this multiplication first before we do addition. So this 2 over 1 times negative 1/2 gives us negative 1. And negative 1 plus 3 is 2, and that is not equal to 4. So no, this is not this order pair is not a solution to our equation. Okay, we're looking at the next equation. And we've got the equation negative 3x plus 4y equals 11. And we are substituting negative 1, 2, checking that to see if that's a solution. And as we substitute negative 1 for x and 2 for y, we get here the multiplication, negative 3 times negative 1, which is equal to 3, plus 4 times 2 is 8, and 3 plus 8 is 11. So yes, that order pair, negative 1, 2, is a solution to our equation. In our next examples, we're going to make our own table of solutions for the given linear equation. And our first equation is y equals 2x minus 3. And notice that we already have pre-chosen for us our x coordinates, our x values. So we're going to substitute and solve for the y value. So we'll start with x equals negative 2. Substitute that into our equation. and solve for y. And when we do that, we get y equals -4 minus 3, or y equals -7. We'll substitute, we'll just write that into our table. Okay, our next y value is x equals to -1. Again, substituting into our original equation, we get y equals -2 minus 3, or y equals -5. Let's write that in here. Now we were looking for the y value to x equals 0. So x equals 0. So y equals 2 times 0 minus 3, or y equals -3. So let's put that in our table. The next coordinate, x coordinate, is x equals to 1. And we substitute. 2 times 1 minus 3 for y. Y equals 2 minus 3, or -1. And you may be seeing a pattern here. You notice that our y values are 2 apart when our x values are 1 apart. So our y value for 2 then must be 1. And that is a nice feature of lines. Now what I want you to, this time what we're going to do is redo the same problem but with the graphing calculator. So the first thing I want you to locate is that y equals button on the upper left hand corner, and you're going to type in our equation. Now the y is already given for you under y1, so we're just going to type in the 2x, 2 times x minus 3. Okay. Now I want you to locate a button that's also in the upper left hand corner. And this one says table set, and this lets us set up our table. Actually, we're going to use our x coordinates. The table start is the first x coordinate that you want in your table, and so we needed that to be -2. And that next line is how far apart are your x coordinates going to be. And so we have consecutive x coordinates that are 1 apart, so we set that to 1. Leave the other 2 set to auto. And now to see your table, locate the table button on the upper right hand corner. You're going to use the blue key, and notice how that will give you the same table that we already computed by hand. So that's pretty cool. You can use your graphing calculator to recreate our tables or to create new tables. So we're going to try this from scratch now with the next problem. And in our next problem we have y equals 1/2 x plus 4. So let's go back to that y equals button and clear that first equation we put in. And I'm going to type in 1/2. I'm putting this in parentheses to make sure that nothing weird happens with that x. So 1/2 in parentheses x plus 4. And then this time when we go to our table set, our table setup, remember that we want to, in this problem, we want x to start at -6. So that table start, we're going to change that to -6. So -6. And notice that our x, we want them to be 2 apart. They're 2 apart. So that second line, we're going to put a 2. Now let's look at the table. And here are our values. And sure enough, there they go from -6 to 6, 2 apart, and there's our y values. And so we can fill in our y coordinates for each of our x coordinates in our table. Makes it real easy with the graphing calculator. So it's good to practice so you can get familiar with that. Let's look at the graph of this linear equation. It's probably not a surprise, since we've been calling it a linear equation in 2 variables, that its graph is a line. So a linear equation in two variables can always be written in this form: ax plus by equals c, where a, b, and c are the coefficients. They are numbers, and we don't want both a and b to be 0. And we've already discovered that the graph of a linear equation is a line. And also we can see that solving the equation for y makes it easier for us certainly to use our graphing calculator to get our table of values. So in this next problem, we have to change the linear equation from its standard form into this, what some of you may already recognize as slope-intercept form, which is solve for y. So we subtracted the 3x to move it over to the other side of the equation. And now we're going to go ahead and type that in. And so we cleared the previous entry, and we type in the negative 3x plus 2. And then we go to the setup. And I'm thinking we can definitely start at negative 6. That seems like a good place to start. And it's okay. Let's leave this the way it is. I'm not going to make any changes, and let's go look at the table. And notice we have some y values that are a bit large for our grid, but we've got at least 3 points in the middle that are within our grid range. So we can use those 3 points to graph this line. Now the first thing we need to do is label our axes. The horizontal axis is x and the vertical one is y. And our first point we're going to graph is point negative 2, 8. So we go left 2 and up 8, and that's our point negative 2, 8. Put a dot there. Our next point is 0, 2. So we stay on the y-axis and go up to 2. And our third point that we're going to use is 2, negative 4. So we go right 2 and down 4. And we're going to take those 3 points and join them in a straight line. And there's our line. There's the graph of our linear equation. And you can check this by using your calculator and using that graph button. Okay, we're to the next example, which is the equation negative 2x plus 6y equals 12. Again, we're going to add 2x, positive 2x to both sides to get that, solve for that y, isolate that y. We're going to have to divide by 6 so that we can get y by itself. And 2 over 6 here, that reduces to the fraction 1/3 x. And 12 divided by 6 is 2. So there's our equation solved for x, for y. So now we're going to go to our graphing calculator so that we can enter this equation. So again, we go into that y equals button. I'm putting my 1/3 in its parentheses there, times x plus 2. Okay, we've got that there in our window. And then let's look at the, let's go to the table setup. This time I want my x's to be 1 apart, so I'm going to go ahead and change that. And then when I look at my table, I notice I get some decimals there, which are some of our fractions. But good thing is I've got 3 nice points with nice integer coordinates, so I'm going to use those to help me graph. You know, go for the easy. So let's label our x and y axes. And let's start with our first. Our first point is negative 6, 0. So that's on the x-axis. And then our second point that we're graphing is negative 3, 1. And our third point is on our y-axis, and it's 0, 2. And we're going to join those 3 points with our line. And there's our line for our equation. Well done.